5, check that the function f of x equals to x plus 3 over 1 plus 2x is bijective and maps its domain, the reals minus 1/2 to reals minus 1/2. Okay, so this is kind of tricky in the sense that what we have defined before in theory for a function to be bijective is that it's a real function defined on R, the reals, and then that it maps the reals to R. Okay, that's what we call bijective before. But in general, in math, we say that the function is bijective if that, and I think you will have seen this on our algebra, is that if we can, let's say, we define the function to be from a domain to an image, and so that every value in the domain of x, so this is x, gets assigned an f of x, so that every value in the domain gets a value in the image, so that this is unique. Okay, so in this case, if we think of this function as defining the reals minus this and mapping to this other set, we have to find that indeed every every point in this set has is mapped to by some point here and only one. So yeah, every point in this set is mapped by one and only one. Okay, so first is to see that the domain of f is the reals minus 1/2, but this is a rational function, and we know that the domain of rational functions is everything, so the whole real line except the points that make the denominator be 0, but it's easy to see that the only point that makes this equal to 0 is minus 1/2. Okay, so that's clearly the domain. And now in order to see how it maps to, what we want is, okay, let's see if I can write function, value y. Okay, and so if I try to solve this equation for x, okay, so that I get something like x is some function g of y, which will actually be the inverse of f, then I can say, oh, so for every y, and we will see if it belongs to this set or not, we can have an x. Okay, so let me explain that. So that if we solve this, then we have y plus 2xy, and then x plus 3, and then so we have x. We want to solve by x for x, so it's 1 minus 2yx, and this is y minus 3. And so we have x and then y minus 3 divided by 1 minus 2y. Okay, so now we have, for every y that we can think of, we can find an x. Okay, but not every y, because if y is equal to 1/2, okay, there is no x that maps to it. Okay, so that's how we prove that the image of this function f is mapping this domain to the reals minus 1/2, because there's no way that we can find any x that gets mapped to 1/2. Okay.